Hi guys, BuildZoid here, and today we're going to be taking a look at some rather interesting overclocking behavior of the SK Hynix GDDR6 memory chips that are on my MSI RTX 3060 Ti Gaming X LHR edition. So, yeah, basically, the relevant stuff... So I have a bunch of mods on the cards, but the only relevant one is the memory voltage control mod. So I have a switch and this potentiometer. The potentiometer allows me to adjust the memory voltage up and down, and the switch is there to disconnect and, connect and disconnect the potentiometer from the ref in circuit of the UP1666 voltage controller that handles the two-phase memory VRM. So... I flick the switch, now we're down at 1.21 volts instead of 1.36 volts. So in this position, it's actually turned off, and you might be like, wait a minute, why would turning the mod on lower the voltage? Well, the interesting behavior with these GDDR6 chips from SK Hynix is that they run a lot better if you give them a really massive undervolt, down to 1.21 volts-ish. Just so that people, because you might not know the spec of GDDR6. So here's all the 8 gigabit GDDR6 memory chips that SK Hynix makes, because I wasn't really bothered to write down what actual part number is on my card, so I have no idea what's actually there. But it's got to be one of these chips. If anything, is probably these right here, because those are currently in mass production. And as you can see, all of these memory chips are specified to run at 1.35 volts. So the card, sitting at 1.36, so with the mod turned off, sitting at 1.358 volts, yeah, that's perfectly normal. The GDDR6 specification allows up to a 3%... 3% margin on the 1.35 volt main power supply rail. So we can basically be at up to 1.39-ish, which we're under that, and you shouldn't go below, and the minimum operating voltage is supposed to be like 1.2 something. Actually, no, 1.3 something. I think it's like 1.32. Yeah, I only calculated the upper boundary because I don't know, we're not getting close to the 3%, minimums that are allowed in the specification. Now, you might be like, isn't this a Micron data sheet? Yes, unfortunately, I can't get a SK Hynix data sheet, so we have to do with a Micron one. And they should all be the same because as far as I know, these supply... power supply specifications for the GDDR6 memory chips are actually from JEDEC, so they're not they shouldn't be manufacturer specific. So anyway, let's run some 3D Mark Times file on this card. Oh, and I guess I should have also showed the voltage control. So that lowers the voltage. And that raises the voltage. I'm going to bring it back down to... that's a bit low. Actually, that'll be fine. It'll be fine. We'll just switch the mod off. So we're going to look at stock configuration here. And so we're going to run some 3D Mark Time Spy Graphics Test 2 because it's nice and heavy on the memory. And we're going to take a look at how much we can overclock the memory on this card, and we're just going to also overclock the core. I have the fan speed at 90%, so temperatures are going to be nice and low. We're going to go to plus 188. The card can bench a little bit higher than that, but I don't really need to... I don't want to deal with crashing right now, so we're going to go with 188, which tends to be pretty stable with the card in its current configuration. And we're just going to, enable windowed mode, and we're going to loop this. And we're just going to run that. The voltage is going to go up a bit because at idle there's not much current flowing out from the memory VRM to the memory chips and the memory controller, so the impedance of the power plane isn't driving up the output voltage too much, because the voltage controller is probably regulating against the memory controller or something. I don't know where exactly it's measuring its output voltage, but I would guess it's somewhere near the memory controller, a far away memory chip, so the voltage right at the VRM ends up going up a little bit when we go under load like this, right? So now we're at 1.375 volts. which is still well within spec, right? Like that's still 15 millivolts below that upper limit of plus 3% on 1.35 volts. So now we're just going to pull up MSI Afterburner and we're going to start overclocking the memory a bit. And we're going to go straight to, oh, I don't know, plus 1,000. Well, plus 999, I think that is. Yep. So we go up to plus 999, and you know it's running nice and easy. Go up to 1100. Well, 1107, still running. 1147, still running. Well, yeah, we're starting to see some artifacting now. It's not great, but hey, let's keep pushing it further. Now we're at 12, and 1200 just crashes the benchmark completely. I'm surprised that didn't take down the drivers, but it did not take down the drivers. So plus 1200 is definitely not going to run. So we're going to drop it down to like 1080, and now we're just going to run the 2 graphics tests of 3D Mark Time Spy. So we're going to turn this off so that we get a score for this current configuration of the card, and then we're going to enable the volt mod. And lower the voltage, not raise it, which is super weird because under, like, my past experience with memory chips on various GPUs has been like, or more memory overclocking on various GPUs has been either you raise the voltage and nothing happens, or you raise the voltage and you get an improvement. I don't really remember ever running into a card where lowering the memory voltage would lead to better overclocking results. But this card with these SK Hynix chips does exactly that. And I'm pretty sure it's due to the SK Hynix chips. Though, you know, I don't have any like Samsung chips or Samsung-based or Micron-based cards to compare against because that would be really expensive. Yeah, that's the downsides of actually having to buy all of your, like, buy GPUs. I've got a limited budget for testing dumb stuff like this. Because the thing is, you can't, unfortunately, do this kind of, like, if you wanted to do, well, once you see, like, if you wanted to undervolt your memory, like I'm about to do here, you do have to physically modify the card. I don't, as far as I can tell, the voltage controller for the memory VRM is not connected in any way, shape, or form to the actual GPU core. So there's no way for the GPU to tell the voltage controller to lower the voltage. It just sits at 1.35 volts to the best of its ability constantly. You know, there's no like power saving mode where it drops the voltage or something like that. There is technically a power saving mode for like disabling an extra phase, but I'm not even sure that's hooked up. So basically, this just sits there and outputs 1.35 volts from the moment the card starts up until the moment you shut it down, or you volt mod it like I did. And that's sort of the only way to get voltage control on these cards, as far as I'm aware. Now, maybe there's some other 3060 Ti's where you wouldn't have to go this far, but I don't think so. Because digitally controllable voltage controllers, and also NVIDIA doesn't really give you, like, and NVIDIA generally won't give you access to voltage controls even if you have a digital controller that would be controllable in software. So this is still artifacting a bit. That's great. It's fine. It should still finish the benchmark though. Yeah, voltage is still, you know, it's getting up there, but it's still in spec, right? Spec is up to 3% above 1.35 volts. So we're still well within spec, and that's... Did it crash? Are you kidding me? I think it crashed right at the end of that test. Yes, it did. Oh, man. Just, like... Way to ruin my video. Or more like unnecessarily extend it. What a stupid card. Okay, we're going to have the... Actually, I'm just going to max the fan speed out this time. And we're going to run 1053 instead of, I think it was like 1080 before. Well, 3D Mark is now all screwed up, so we're just going to restart that. So that's really great. I'm just going to turn off the physics test so that I don't have to escape out of it. Now, I shouldn't really call it a physics test because it's not actually a physics test. It's like that weird fractal thing. Well, I'm not even sure it's a fractal. Like that, it's that weird like growing stuff thing. It's not really a physics simulation. That's probably not a fractal. It's not very regular. It's kind of a random mess. Well, it's not random in that it renders the same thing every time, but... or more like animates the same thing every time. It doesn't really matter. Because I do want to score for the sake of, performance comparison here. So that's why we're rerunning this, even though, like, I'm really annoyed it crashed right at the end. Unfortunately, you can't just run one of the tests. Or, well, I can't figure out where in the UI it shows you the per test FPS. That's basically the issue. So we have to run both of them so that we actually get a score. Because the score is literally just some, like, multiplication of the frame rate that you get when running the benchmark, so... So basically, like, it ultimately is still a measure of FPS, it's just not in FPS. And there's no, like, there's no weird scaling to it. It's completely linear. If your frame rate goes up 2%, then your benchmark score goes up 2%, so, yeah. I'm not entirely sure why they don't show FPS. Well, actually, they do, but again, I've forgotten where they put that in the UI. Okay, so this should be finishing pretty quickly. Or, well, pretty soon, because it's a little over a minute for this test. Yep. So that's that. So that's 1053, and we get a score of 13,150 points. Lovely. And so now we're going to rerun that with way more memory clock. So I'm just going to turn the volt mod on. So we're down at 1.206 volts now, and I am going to raise that memory frequency slider all the way to like 1512. And that'll actually work. That'll run. I'm a bit worried, like, the thing is, now that the card's a bit warmed up from that previous run, the score might not go up as much as you might hope it would. But, yeah, also I'm starting to think that the memory... Like, the card doesn't really scale a ton from memory clock as far as I can tell, so I suspect that the core is just not that bandwidth starved. Which kind of makes sense. Like, the memory controller on this is designed for the 3070, and we already know from the 3070 Ti that this core doesn't really need significantly more memory bandwidth, even in, like, the full configuration that the 3070 has, right? Because the performance difference between a 3070 and a 3070 Ti is basically nothing, but the 3070 Ti is on GDDR6X, so that has significantly more memory bandwidth, and yet the impact on the overall performance is pretty minor. So with the 3060 Ti pushing these kinds of crazy memory speeds, unfortunately, it really doesn't seem to do much. Or, well, crazy. I mean, at this point, it's not really that crazy. Like, there's Samsung cards that I've seen pictured doing similar clocks without any crazy modifications. Are you kidding me? Did it just crash? I think I gave it too little voltage. There's definitely a lower boundary for the voltage, or it's too hot. I'm just going to wait for it to cool down this time. Nope. Max the fan speed. So we're at 31. Taking a while to drop. Oh, what was the max temperature? That shouldn't have crashed it. I don't think. Especially since, yeah, it didn't even reach that in GT1. Well, let's try that again. I had a previous take of this video where this, like, I didn't have any unexpected benchmark crashes. I think I was also running a lower core clock for it, though. So that might be part of it. I scrapped that take because I didn't like it. So... if this crashes again, I might scrap this one too. I should have just left the core clock lower. There's really, like, 188 is pretty close to the limit. Like, yeah, that's actually really close to the limits of what this card will do for Time Spy. And the boost algorithm not running really the exact same clocks every single time you run the benchmark makes that kind of awkward. Though I might have also set the memory voltage too low. Like, I've spent enough time fiddling with the memory voltage to notice the, like, it runs way better at, like, crazy low voltage relative to the stock specification. I've not yet figured out what exactly is, like, the optimal amount of voltage. You know, we might be a little bit too low right now. It certainly doesn't run properly below, like, or, like, it gets significant, like, once you go below, like, 1.19 volts, it starts getting actually significantly worse in terms of stability. So maybe, like, 1.25 volts would be optimal, or like 1.24, not entirely sure. Yeah, takes, you know, like, but either way, like, even with this sort of, I don't think I'm too far away from maxed out, because, like, the highest frequency I've actually gotten to finish Time Spy whatsoever was, like, 1600 on the memory. But at that point, it was artifacting a lot. So, yeah, we're probably pretty like, we're probably not far off of where this runs best, but I'm not sure where exactly that is yet. Also, I might really be pushing the core a little bit too far. It's been really warm recently. Like, last 2 days here in the UK have been, well, really warm. Just, like, it was raining for, like, a week, or, well, it was relatively cold for, like, a week, and now it's, like, super warm. Anyway, and the score barely changed, yeah. That's the sort of the annoying thing here, is just, it might be, like, some minor, like, there might be some error correction or something going on, but the thing is, this is just not a great score in general, for this card with these settings. Like, I've seen it spit out. Let's just go through the results that I had on my previous take. In my previous take, it did 13,245. So about, like, 60 points more than what we got right now. So yeah, this just doesn't seem to be a very good run in general. Might be too hot. Might be a bit unstable. I'm not entirely sure what it is. Could also just be run-to-run variance, right? Like, losing 60 points on a score that has 4-digit, actually that's a 5-digit score, is, like, well, it's like 0.6% or less. Yep, that's, like, less than 0.6% of the, you know, like, the total score. So run-to-run variance is probably, you know, not helping here. But anyway, so at 1.215 volts, you know, we can run plus 1500, and the memory clocks are down right now, so we're just going to switch it back to stock. Right, and I know, like, we'll see, like, well, just to show you how drastic the difference is. Because if we're back at stock voltage, it's going to just crash basically instantly. I'm surprised that it'll get into the benchmark, because I've had it crash on desktop sometimes. With the stock voltage at this kind of memory clock. And there we go, yeah. So basically we got, like, 2 frames rendered, and then you know, it crashed. Now the cool thing is, I don't think the driver reset. Nope, it crashed so quickly and so cleanly that the driver didn't reset, so we're just going to flick the voltage right back down to 1.215 volts, and we're just going to run Time Spy again. And now it should pass. Like, we're not going to go through, like, both tests again. I don't really think that's worth it. But yeah, like, it's not crashing. You undervolt the memory by like 130 millivolts or 140, and stable now, which is just super weird. Like, I really... Like, this is the first time I've run into something like this. Like, it's not that uncommon that you get memory chips that if you keep shoving more and more voltage into them, they get more, like, less unstable, more less stable past a certain point, right? Samsung C-Die is a perfect example of that. But Samsung C-Die stock specification is 1.2 volts, right? Like, Samsung C-Die and all DDR4 is designed to run at 1.2 volts. And so it's not really surprising that when you go over 1.32 or 1.33 or 1.35 volts, like somewhere between 1.3 and 1.4 volts, you're gonna pass a voltage past which you basically start losing stability. And so that's not too surprising because, stock specification is like 1.2 volts. There's a bunch of memory chips that do stuff like that. I think like Samsung and actually at at high frequencies, you can also run into things like, going past a certain voltage level causes more and more instability. So like Samsung E-Die, if you're pushing it for really high frequency, actually has like a voltage sweet spot, depending on the memory stick and the PCB and what motherboard you're on and what CPU you're on. But there's going to be like a voltage sweet spot where it clocks highest. And then, but like all of these happen way above the stock specification from the manufacturer. And then we have these SK Hynix GDDR6 chips, which, they don't run properly on the spec voltage. Or more like they don't overclock properly on the spec voltage. They run just fine, right? Like, as long as you're not overclocking them, they're fine. There's no issues with these. But if you intend to overclock them, you actually want to be running them at like way below stock voltage. Which is super weird. Now, why would this happen? I think it's actually a signal integrity issue that is occurring with these memory chips. And the reason I think that is, so sort of the two main factors like that your voltage is going to affect is going to be like your power draw of your memory chips, but also the power, like the VDD rail for your memory chips. So the main voltage power supply for GDDR6 is also used for the actual signaling to and from the memory controller. So at 1.35 volts, you're going to have much sharper slopes on your rising and your rising and falling edges are going to be much steeper if you're at 1.35 volts than if you're at 1.23 volts, which means that potentially at 1.35 volts, and this is just a theory, I don't know for sure. The reason I don't think it's a thermal thing is because it's instant. If we go runtime spy, we don't even get 2 frames. It just crashes the moment the benchmark starts when you're running this kind of frequency if you're at stock voltage. But when you run it at less than stock voltage, it runs the whole thing just fine. Or relatively fine, right? And this time we actually got the kind of score that I was hoping for, a 13.265, not bad. Yeah, so, with this much lower voltage, it runs just fine. If the higher voltage, it's just instantly unstable at these higher frequencies. And so I don't think it's a thermal effect, because if it was a thermal effect, you would expect it to have some delay in how quickly it kicks in. There'd be some sort of build-up to the instability showing up, but no, it just immediately becomes less stable. So I think it's a signaling thing, because the Micron documentation is kind of neat for this as well, as they have this lovely diagram right at the bottom that I'm not entirely certain that I'm reading it correctly. Oh, whoa, it's rendering very differently here. Where, this is sort of the data signaling waveform. And you can see that, up here we have VDDQ, and this signal goes up to VDDQ. And I'm not entirely sure why it levels off a little bit below that, or at VOH, which is for output high. The OH stands for output high, and then you have OL, which stands for output low. And this is maximum level of output low, and then there's margin. So, you know, there's, because like you can see that even the waveform diagram has all of this noise in it. And so the memory controllers and the memory chips are designed to have some tolerance for distortion in the signal. But basically what I think is happening with these SK Hynix chips is that at the stock 1.35 volts, this distortion is really big, like way bigger than at 1.23 volts. And so at 1.23 volts, you can run higher, like faster memory speeds because there's less distortion in the signal. And so the memory controller has can actually reliably distinguish between ones and zeros, because if the signal is super distorted, things that should be a 1 might look like a 0, and things that should be a 0 might look like a 1. And so then the memory controller, and that's where you get all of your glitching, because your data starts getting corrupted because the memory controller can't distinguish between a 1 and a 0 reliably anymore. But that's just my theory on why this happens, because it does happen immediately. There's not really any buildup. Cranking up the fan speed doesn't really change the behavior very much in my experience. It would be really cool if I had an oscilloscope that was like capable of measuring it, though I'm pretty sure hooking up an oscilloscope to like a running GDDR6 memory system would probably cause it to get incredibly unstable. Though I'm pretty sure they design probes even for probing GDDR memory systems. I do not want to even like speculate as to how insanely expensive those have to be. Yeah, so that's my theory on why, the SK Hynix chips seem to run, well, they don't seem to run. They overclock way better on 1.23 volts. Now, of course, the stock 1.35 volt specification, like, they run stock fine, and so SK Hynix doesn't really care because they spec these chips to run at 7 gigahertz, which, funnily enough, that is an actual frequency for GDDR6, and now we're getting off track in this video, because GDDR6 has, like, a bunch of, so you have, this GDDR6 is super weird. So you have your, like, main clock, then you have whatever the hell this is, which runs at 3 gigabits per second, so that's double your, like, base clock. So this is the memory frequency that you see in GPU-Z. This is the memory frequency that you see in Afterburner, and this is the actual, like, data rate of the memory chips. So and then there's alternatively, there's the QDR-WCK, which I believe that stands for write clock. I'm not sure. Like, again, I'm bad at RAM overclocking. Just, like, I'm serious about that. I'm bad at RAM overclocking. I skim these data sheets. So, anyway, so you basically have all of these different clocks. So this is the clock that you see in Afterburner. Technically, there is actually, like, a 7 gigahertz clock going to the memory chips, which that's kind of insane to consider. Anyway, so if you massively undervolt your SK Hynix GDDR6, it overclocks way better than if you run it at stock settings, which is, in my opinion, super weird. And also, I think it's because of the signal integrity thing. I don't think it's a temperature thing, because, well, I don't really have proof for that. I guess what I could do is, like, try run the memory chips at 1.35 volts and, like, well, not really viable. Like, basically, if you could, like, cool down the memory chips a lot, specifically just the memory chips and not also the GPU, right? Then, though I guess maybe no, I don't think the memory controller cares, because the thing is, like, there's cards with Samsung chips and Micron chips doing these kinds of clocks at stock settings, or at least close to these kind. I think this is at this point clocked about as high as the highest card on HW bought. I've not checked the 3D Mark rankings for the memory, at least, not for the core. And so, I'm not sure that. Well, basically, the SK Hynix cards have a reputation for clocking like garbage compared to the Micron and the Samsung cards, and so I don't think it's a memory controller thing, or more like, I don't think the memory controller particularly cares about 1.35 volts, because the other cards all run on, like, all of these cards at stock run at 1.35 volts, and yet the SK Hynix ones clock, significant, well, somewhat worse. No, I wouldn't say it's significant. It's like 100 megahertz, not really a huge deal, especially on a chip that doesn't really seem to be limited by memory bandwidth, right? On a 3070, this might actually be a big deal, but on a 3060 Ti, I don't think there's really enough cores to care too much. As you can see, like, the score barely changed, which is pretty frustrating considering how much work I put into this card. Well, actually, when I first started working on this card, I was struggling to get up, like, I was struggling to get to 13,000, so... but there's other modifications on there, so that's not, you know, that's not entirely the memory's fault. Yeah, so that's kind of it for the video. And unfortunately, if you wanted to copy this modification to improve the memory overclocking of your SK Hynix based GPU, you would have to physically modify the card. Like, I'm really not aware of any way you could do this in software, because as far as I know, the voltage controller is analog and it is not connected to anything except its own reference its own reference voltage circuitry. So, yeah, if you want to do something like this, bye-bye warranty. Yeah, that's it for the video. I will be covering all of the modifications and how they're, like, we'll be covering all the modifications that I have on this card in future videos, so we'll cover how, like, to actually set up this volt mod, how to set up the core voltage mod, and all the other stuff in later videos. But yeah, this, I thought, deserved its own dedicated video, because it's super, like, it's weird. Like, I've really not run into a freaking, like... Going below stock generally doesn't lead to better overclocking results unless you're cooling limited, right? Like, that's the thing, is, like, if you don't have enough cooling, sure. But the thing is, I have the fans maxed out. These are short benchmarks. The chips aren't getting hot. They're just not stable at 1.35 volts. So, anyway... Yeah, okay, I'll actually end the video now, so thanks for watching. Like, share, subscribe, leave any comments, questions, suggestions down in the comment section below. If you'd like to support what I do here with actually hardcore overclocking, I have a Patreon. There's a link to that down in the description below. There's also the HOC Teespring store where you can pick up shirts, stickers, posters, you know, the usual YouTuber merch. The Patreon and Teespring help out immensely with running the channel because, well, without them, I wouldn't have this 3060 Ti. I had to buy this thing. So... yeah, it would be much appreciated if you'd check out the Patreon and Teespring. And yeah, that's it for the video, so thanks for watching, and goodbye.